Integrations of trigonometric functions we are going to learn here by using trigonometric identities and also by trigonometric substitutions. Various types of trigonometric functions, how to integrate, we are going to learn here. First, we are considering questions with sine and cos even powers. Sine square x, cos square x, sine power 4x, cos power 4x. Even powers we are considering here. And for even power, that is either sine square cos square or sine power 4 cos power 4. For even power, we must use the identities 2 sine square theta is equal to 1 minus cos 2 theta, and another identity is for 2 cos square is 1 plus cos 2 theta. These two identities we must use for integrating these questions. Sine square theta, if we find from here, it is 1 minus cos 2 theta by 2. For sine power 2, sine power 4, sine power 6, we must use this sine formula. And identity for cos, from here, cos square theta is 1 plus cos 2 theta divided by 2. For cos, even power of cos, we must use this identity. And no other way is there. This identity is the we must use for integrating even power of sine and cos. Now let us integrate the first question, that is integration sine square x. We must use this identity, sine identity. We have sine square theta is 1 minus cos 2 theta divided by 2. This is the identity we are going to use for sine square. So integration of sine square is 1 minus cos 2 theta divided by 2. So it is in terms of x. The question we have taken is in terms of x dx. Now we'll separate. We can split into 2. 1 by 2 minus cos 2x by 2. And then integration of first minus integration of second. Completely we'll separate. Integration of first minus integration of second. The two terms are completely separated under two integrals. And here this 1 by 2 is constant. We can take it out common. Will remain 1 dx. Here also 1 by 2 is constant. We can take it out. And then both the terms are under basic formula of integration. Integration 1 dx is x and integration cos is sine. Integration of cos is sine. And in integration we know we must divide by coefficient. Coefficient of x here it is 2. So divide by 2. Integration is done. We must write plus constant. So it is 1 by 2x minus 1 by 4 sine 2x dx plus constant. So any even power of sine and cos, we must use the two identities. This is for sine square and this is for cos square. Now let us do the third question, sine power 4x. Now let us solve the third question, sine power 4x. Power 4 we must write like this, square whole square, correct. 2 to the 4 power, correct. Now here inside you use the identity. We have written sine square theta is 1 minus cos 2 theta by 2. We will use this identity. So we are getting 1 minus cos 2x divided by 2. Whole square is there. Sine square is this. This is the identity. Whole square is still there. And then in the numerator now we will apply a minus b square formula. We will expand it first. So this 2 also is having square. 2 square is 4. A minus b whole square formula, a square minus twice ab plus b square dx. Let us simplify. 1 minus 2 cos 2x plus, it is cos square 2x by 4. Now we must use the cos identity here again, cos square. any even power, we must use the two identities, sine square and cos square. Here we are going to use cos square. We have learned cos square theta is 1 plus cos 2 theta divided by 2. Now here theta is 2x, cos square theta is 2x here. So let us use this identity. It is 1 minus 2 cos 2x plus cos square theta 1 plus cos twice theta is 2x here, divided by 2 divided by 4. It is as it is. Now we can simplify the numerator, taking LCM, simplify. Now just simplifying this identity we have used, and we are just simplifying, taking LCM and simplifying. 4 by 1 taken reciprocal here, then 4 to the 8 will separate completely. 4 to the 8, so we can make it 3 by 8 minus 4 by 8 cos 2x plus 1 by 8 cos 4x. All the terms are separated now. All the 2 4 the 8, so all the terms are separated. Now we can the numbers we can keep it out of integration, and all the terms we are separating the integrals. 3 by 8 out, it will remain 1 dx. 4 by 8 taken out, cos 2x dx integration. 1 by 8 taken out, cos 4x dx. And now all the terms are under basic integration. 3 by 8 integration dx is x, basic integration. 4 by 8 1 by 2 integration of cos is sine, divided by coefficient of x. Then integration of cos is again sine only, divided by coefficient of x, integration over plus constant. We can write more terms, simplifying the numeric part. And any mistake in simplification, plus minus, that you can do the correction easily. So integrations of even powers of sine and cos we have learned. Now we will learn integration of power 3, sine power 3x, integration of sine power 3x, and then integration of cos power 3x dx. Let us learn this. For this we are going to use identity. We have identity sine 3x is 3 sine x minus 3 sine x minus 4 sine cube x. And for cos we have another identity. These are identities. Cos 3x identity. Okay, I have written the identities. See, for sine cube and cos cube, we must use these two identities. Sine 3x is 3 sine x minus 4 sine cube x. From this identity, we are finding sine cube. And we have learned another identity is cos 3x. Cos 3x identity, 4 cos cube x minus 3 cos x. And from this identity, we are finding cos cube. So integration of sine cube and cos cube, we must use these identities. For sine cube, this identity, and for cos cube, this identity. Now let us integrate the first one. First question, sine cube x dx. This is the identity we have explained here. Sine cube is 3 sine x minus sine 3x divided by 4. Sine cube, this is the identity. Now we will split the integrals. First integral by 4, second by 4. Now integration of first, integration of second, we can completely separate. 3 by 4, keeping it out because constant. So only sin x dx. Here 1 by 4 is out. Second term will remain sin 3x dx. And now both the integrals are under the basic integration formula. Integration of sine is minus cos, keep bracket. Integration of sine is again minus cos, divide by coefficient of x, that is 3. Integration is over, we have to write plus constant c, and then we can write one more step, that is minus 3 by 4 cos x plus minus minus plus 1 by 12 plus constant. So the integration is done. Now let us integrate the second question. Integration of cos cube x dx. For cos cube, this is the identity we have explained. We must use this identity for cos cube. So cos 3x plus 3 cos x divided by 4. So same as before, we'll first split it. First term by 4 plus second term by 4, cos 3x by 4 plus second term 3 cos x, that is divided by 4. And then the two integrals completely separating. Here 1 by 4 keeping out in the first integral, cos 3x dx. Second integral 3 by 4 keeping out, cos x dx. And now both the integrals are under the basic integration formula. Integration of cos is sine 3x divided by coefficient of x is 3. Integration of cos is plus sine plus constant c. The integration is done. So this is the way to integrate sine cube and cos cube. Now for these questions, again, these are all the 4 questions I have taken here are under sine cube and cos cube only. Now let us integrate one question. This one, integration of sine cube ax plus b. Then at first we will do substitution. Ax plus b is equal to t. We will do substitution at first, and therefore d dx of ax plus b, substitution method we are doing. Then a into x1, b no x, differentiation 0 is dt by dx. Then dx is converted 1 by a into dt. Then the integration is converting, it is sine cube t. This function we have taken t, and dx we have converted, dx is 1 by a dt. Then 1 by a is taking out, and sine cube t dt, sine cube. Now it will be done by same as the previous questions. Just now the question we have done, sine cube under the trigonometric identity. So it is sine cube x, it is under the trigonometric identity now. So it is sine t minus sine 3t divided by 4, and then we can easily do the integration. All the remaining questions, all these questions will be done in the same way. Here you will put 2x plus 1 is equal to t, and first you do substitution, and then like this it will come under trigonometric identity, sine cube or cos cube. Here you will put 2x plus 1 equal to t. This one we have done, and for this again same process, you will put ax plus b equal to t. Initially you will do substitution, then the question it will be under, this is cos, so it will be under cos cube identity. We can easily integrate it. Now next questions we are taking of this form, sine cos, sine sine, sine cos, product of sine and cos, maybe 2 terms, maybe 3 terms. Here product of 3 terms. The integration type is, here the integrations are product of sine and cos, maybe product of sine sine, cos cos, or sine cos mix up, maybe 2 terms, maybe 3 terms. And for these types of integrations we must use these identities given here. 2 sine a cos b, cos a sine b, cos a cos b, sine a sine b, product of sine and cos. So these are the identities we have to use. 2 sine a cos b, sine a plus b plus sine a minus b, cos a sine b, sine a plus b minus sine a minus. These identities coming from this 4 identities actually coming from the very basic trigonometric formula, trigonometric identities, compound angle formula. Sine of a plus b, sine a cos b, cos a sine b, sine a minus b, cos a plus b. These are the most basic formula of compound angle in trigonometry. Now if we add equation 1 and 2, if 1 and 2 if we add, we are getting the first identity, sine a cos b. If we subtract 1, subtracting 2 from 1, we are doing 1 minus 2, getting the second identity. Similarly 3 plus 4 another identity, and 4 minus 3 another identity. These are the identities we are obtaining from this compound angle formula. Now product of sine and cos, any integral with product of sine and cos, we must use these identities. Now let us do the first question. Now we are integrating the first question. It is sine 3x cos 4x. For convenience, you can take the bigger one first. Bigger angle, we can interchange cos 4x into sine 3x dx. Now it is cos sine. So cos sine product, cos sine, this second identity, cos and sine product, we have to use the second identity. Now we need 2 there, so we'll divide by 2, multiply by 2. Cos 4x sine 3x dx. Now we are going to use this second identity. 2 cos sine b is sine a plus b minus sine a minus b. So 2 cos sine b is sine a plus b minus sine a minus b. Sine a plus b, 4x plus 3x, sine a plus b minus sine a minus b, 4x minus 3x. We can very easily do the integration now. So identity is applied. It is sine 7x and this is sine x. Now we can separate the integrals. Integration first term minus 1 by 2 common, integration second term. Now both are under the basic integration formula. Integration sine is minus cos divided by coefficient of x. Integration sine is minus cos. The integration is done. There will be plus constant c. So we can write one more step, 1 by 14 cos 7x plus 1 by 2 cos x plus constant. So the integration is done. Now let us integrate the second question. It is sine 4x sine 8x. For convenience, we can bring the bigger angle first so that minus sign will not come. Sine 8x sine 4x. It is product of sine, the last identity, sine product. We need 2 there, so we'll divide by 2, multiply by 2. And then let us use this identity. 2 sin a sin b, cos a minus b minus cos a plus b. It is cos a minus b, cos 8x minus 4x, cos a minus b minus cos a plus b, cos 8x plus 4x. Now we can easily do the integration. It is cos 4x and this is cos 12x. Now separate. Integration first term minus 1 by 2 common again, integration cos 12 second x, and both the integrals are under basic integration. It is integration of cos is sine, divide by coefficient of x, integration of cos is sine, divide by coefficient of x is 12 plus constant. We can write one more step, simplifying the numeric part. Now let us integrate the third and fourth, same product of 3 terms, no problem. We can take any 2 terms at first, first, second, or first, third, second, third, any 2 factors first, third factor will keep as it is, and then we will apply the process. Now, third question, it is cos 2x, cos 4x, cos 8x. We will take any 2 factors first. We can keep cos 2x as it is, and then here cos 4x, cos 8x and cos 4x, just interchanging, bringing bigger one first. These 2 we can take together, and then we will apply the process. Cos identity is this third identity, 2 cos a cos b, cos a plus b plus cos a minus b, third identity. But we need 2 there. So 1 by 2 multiply by 2, cos 8x, cos 4x. So 2 cos a cos b. This is the identity, cos a plus b plus cos a minus b. Let us apply it. This 1 by 2 we can take out, it is constant. This 2 and this 1 by 2 we cannot cancel. This is algebraic, this is angle inside the cos. Now here cos a plus b plus cos a minus b, cos a plus b plus cos a minus b. So we have applied the identity. Then it is cos 12x plus cos 4x. Now we'll multiply cos 2x into cos 12x. So we can interchange cos 12x into cos 2x. These two product first and this into this again. So it is cos 4x into cos 2x. Just multiply this into this here, this into this here, just multiply it. Then we'll separate completely. It is cos 12x cos, this is 2x dx minus plus 1 by 2 common again, 1 by 2 cos 4x into this is cos 2x dx. Now it is product of 2. Again we can apply cos A cos B formula here, cos A cos B formula here, and we can easily do the integration. We can easily do it. Let us do it. So it is product of cos cos, here also product of cos cos. So we are applying again cos formula, 2 cos A cos B identity. Same identity we have applied here also, and then we easily got the integration. Now solving some questions from NCERT textbook. This question we have to use the identities. 1 plus cos theta is 2 cos square theta by 2, and 1 minus cos theta is 2 sin square theta by 2. We have to use this identity for this question. 1 minus cos is 2 sin square x by 2. This is 2 cos square x by 2. 2 is getting cancelled. Sin square by cos square is 10 square. 10 square. Now in integration 10 square there is no formula. So in integration 10 square must be always converted to sec square minus 1. In integration 10 square no formula, but sec square formula we have. So this 10 square we are converting into sec square minus 1. And then separating the integrals. Sec square x by 2 dx minus 1 dx. Integration of sec square, it is 10 minus integration 1 dx is x. Both are basic integration formula, and here we must divide by coefficient of x. Integration of sec square is 10, correct, but we must divide by coefficient of x. Coefficient of x is here 1 by 2, and integration is over plus constant 1 by 2 reciprocal take, it is 2 10x by 2 minus x plus constant. This is the complete integration. The next question is integration cos x by 1 plus cos x. So here we have to use identity. Identity cos x is cos square x by 2 minus sin square x by 2. This is one identity. And for 1 plus cos x we have to use 2 cos square x by 2. These are the identity we have to use for this question. Cos x, cos square x by 2 minus sin square x by 2. 1 plus cos x, 2 cos square x by 2 dx. And then we'll split first term by denominator minus second term by denominator. We have split it, we have divided first term by denominator here, second term by denominator here, and then Simplify, this is 1 by 2 minus 1 by 2 sine by cos is tan square, and then we'll split into 2. We'll divide integration of first minus integration second dx. 1 by 2 is taken out, it is constant. Integration of 1 dx. Here also 1 by 2 is taken out, it is constant. Now in integration tan square, there is no formula of integration, so tan square must be converted into sec square minus 1. Sec square we have the integration formula, but tan square there is no, so we have to use the identity. Tan square is sec square minus 1. This integration is done. Integration sec square x by 2 dx minus plus 1 by 2 1 dx. Now this is basic formula of integration. This is also basic formula. Integration sec square is 10 divided by coefficient of x. Coefficient of x is 1 by 2, and integration of 1 dx is x. Integration is over plus constant, and then can write one more step. The next question is sine square by 1 plus cos square. Here you will use the identity. Sine square is 1 minus cos square, and 1 plus cos is 2 cos square x by 2. These are the identities we will be using here. Let us use sine square is 1 minus cos square. No, we do not need this identity. Denominator, it will be easily, we can get it 1 plus cos x dx. Denominator as it is. Now numerator 1 we can make 1 square, and we can use a square minus b square formula, a minus b into a plus b. So the integration, it is 1 minus cos x into 1 plus cos x. We are using this formula in the numerator, and then this term is getting cancelled, so integration is becoming easy. It is 1 minus cos x, which can be written as 1 dx minus, we are splitting integration of first, integration, the two integration we have split into separately. Integration of dx is x, integration of cos is sine plus constant. The integration is done. Next question is cos 2x minus cos 2 alpha by cos x minus cos alpha. Here we are going to use this identity, 2 cos square x. From here we can find out cos 2x. Cos 2x will be 2 cos square x minus 1. We will use this identity in the numerator. Denominator keeping as it is. So cos 2x is 2 cos square x minus 1. Same cos 2 alpha, 2 cos square alpha minus 1. Then simplify. Two cos square x minus 1 minus 2 cos square alpha minus plus 1, and then this is getting cancelled. Numerator take 2 common, cos square x minus cos square alpha by cos x minus cos alpha dx. Now in numerator we can use a square minus b square, that is a minus b into a plus b. We can use this formula in the numerator, so we will be getting cos x minus cos alpha, a minus b into a plus b divided by denominator as it is. Then this term is getting cancelled. It is remaining 2 cos x plus 2 cos alpha. Now integration separate. Integration of first, 2 is keeping out, cos x dx. Here 2 cos alpha dx. Integration of cos is sine. In this case 2 and cos alpha both are constant. 2 is constant, cos alpha also constant, will remain only 1 dx. Cos alpha, there is no x, it is constant, taken out of integration. 2 sin x, 2 cos alpha into integration of dx is x plus constant c. Next question, cos x minus sin x by 1 plus sin 2x. For this, we can use the identity Sine 2x is 2 sine x cos x. For this we will use this, and for 1 we can write 1 is equal to sine square plus cos square. These are the two identity we'll use here. Numerator keeping same, cos x minus sine x. In place of 1, writing sine square x plus cos square x. 1 is sine square plus cos square. Then sine 2x is 2 sine x cos x. Now the denominator is coming a square plus b square plus 2ab formula, which can be written as a plus b whole square. So it is sin x plus cos x whole square dx. Then this one we have to do by substitution method. Put denominator is equal to t. Sin x plus cos x is equal to t. Substitution method using trigonometric identities, as well as now we have to do substitution. Then differentiating both sides, substitution method which we have done in exercise 7.2. Now sin x plus cos x is equal to ddx of t. Differentiation of sin is cos, differentiation of cos minus sin is dt by dx, and then we'll find dx transferring other terms to the right hand side. 1 minus cos x, 1 by cos minus sin into dt. This is dt. dt is remaining. dx is taken here. Then the integration is changing now. Denominator we have taken t. Power is there. Numerator as it is. And then this dx we have converted. dx we have converted. It is here 1 by cos x minus sin x into dt. And then this term is getting cancelled, remaining t to the power minus 2 dt. Now it is the integration matching with the basic formula x power n dx. It is matching with x power n dx. It is x power n plus 1 by n plus 1 plus constant. We can use it. And then t power minus 1 by minus 1. So it is finally minus 1 by t, and then we are putting the t. T should be removed. T is taken for sine plus cos, so it is 1 by sine x plus cos x plus constant, and this is the complete solution. The next integration question is tan cube 2x into sec 2x. This one we can do like this, substitution method. Put sec 2x is equal to t, then differentiate both sides. ddx of sec 2x, ddx of t. Differentiation of sec is sec 10. ddx of sec x we know sec x tan x, so it is sec 2x into tan 2x. Into ddx of 2x will be 2. Chain rule, ddx of 2x again 2 dt by dx. And then we can find out dx. dx is 1 by 2 sec 2x tan 2x into dt. Then the integration is changing. The integration is changing. Tan cube 2x remaining same. Sec 2x we have taken t into dx is converted here. dx is 1 by 2 sec 2x into tan 2x into dt. Now tan cube and 1 tan will get cancelled, will remain tan square 2x t, and 1 by sec x 2 sec 2x we have taken t again, so we can put here t into dt, and this t is getting cancelled, remaining only 1 by 2 tan square 2x. And integration of tan square is sec square. We have to integration of tan square, there is no formula, we have to use the identity. Tan square theta is sec square theta minus 1. In integration we should always use for tan square this identity, because tan square we have no formula of integration, but sec square we have the formula. So it is sec square 2x minus 1 dx, and then separate 1 by 2 into sec square 2x dx minus 1 by 2 into again integration 1 dx. And now this is the basic integration formula. Sec square integration is 10. We should divide by coefficient of x. Integration of dx is x plus constant, and this is the solution. It is dt, it is not dx, it is dt, it is dt. So this integration not possible. It is in terms of not x, it is mistake, we have done mistake. This is x and this is t, not possible. So this sec square will be t square minus 1 dt, because sec 2x we have taken t, sec 2x is taken t, so sec square is t square. The integration in terms of x and dt not possible, it is wrong. So we have to convert it. We must do in terms of either t or in terms of x. So we are doing here integration only in terms of t. So it is 1 by 2 t square dt minus 1 by 2 t dt. So t square, it is n plus 1 by n plus 1. Here it is integration of t dt is t square by 2 plus, so this is 1 dt, integration of 1 dt is t plus constant. So it is t cube by 3 minus half of t plus constant, and then t must be removed. T we have taken for sec 2x 1 by 6, t is taken for sec 2x, so we'll put it back. So it will be sec cube 2x by 3, 3 to the 6, it is taken here, minus t is sec 2x plus constant, and this is the complete integration. Next question is 10 power 4x dx. Integration 10 power 4x dx. We can make it like this: 10 square x into another 10 square x dx. 10 square into 10 square. First 10 square keep as it is. Second 10 square we can convert into sec square using identity sec square minus 1 dx. And then this 10 square converted sec square minus 1 using identity, and then we'll multiply. It is 10 square x into sec square x minus 10 square x into 1, and then we'll split into 2. 10 square x into sec square x dx minus this 10 square, integration of 10 square we don't have the formula, so 10 square will be converted into sec square minus 1. 10 square theta is sec square theta minus 1, which we have used here also. First integration keeping as it is. 10 square is sec square minus 1. Then sec squared x dx minus minus plus 1 integration 1 dx. Integration of sec square x is 10x. Integration of 1 dx is x. Now this first integration we have to do it by substitution method. Here for this first integral put 10x equal to t. Substitution method, 10x equal to t. Therefore ddx of 10x is equal to ddx of t. Differentiation of 10 is sec square x equal to dt by dx. Then we'll convert, we'll find out dx here. Dx will be 1 by sec square x dt. So this first integral it will be converted now. 10 is taken t, so it is t square. Sec square x is there, and dx we have converted here. Dx is 1 by sec square x into dt. This is dx. Second term, this integration is already done. 10x plus x. Now sec square is getting cancelled. It is t square dt. Second and third term remaining same. This is now coming under basic integration formula. It is n plus 1 by n plus 1. So it is t cube by 3 minus 10x. T we have taken for 10x. T is taken for 10x, so it is coming out 10 cube x by 3 minus 10x plus x. Integration is complete, plus constant c. T is taken for 10x, so we have put it back, and this is the integration complete solution. The next question is sine cube cos cube by sine square cos square. First we will split it. First term by denominator. Plus second term by denominator. We are splitting into two. First term by denominator here, second term by denominator. Then getting cancelled. It is remaining sin x by cos square x plus cos x by sin square x. Now we can write it like this: 1 by cos into sin by cos. 1 by cos sin by cos. Here we can write 1 by sin into cos by sin. We are just doing simplification. Just simplification doing. Now cos into cos is cos square, so it is correct. Here also sin into sin, sin square, so it is correct. Now basic identity is trigonometric. 1 by cos is sec, sin by cos is tan, 1 by sin cosec, cos by sin is cot. Basic identities trigonometric. Then separate into sec x tan x dx. Integration of first plus integration of second. So the two integrals separated, and both the integrals are now coming under basic integration. Integration of sec x tan x dx is sec x. You can see opposite also. Opposite, inverse process of differentiation. Dx of sec x is sec x tan x. So integration of sec x tan x is sec x. Cosec x, cot x is minus cosec integration minus cosec x. The integration is done, plus constant c. The next question is cos 2x plus 2 sin square by cos square. We will use the identity at first. We have identity cos 2x is cos square x minus sin square x. This identity we will use at first. So cos 2x is cos square x minus sin square x. 2 sin square x as it is, denominator also keeping as it is. Then these two combined, these two combined, 2 sin square minus sin square, cos square remaining same, 2 sin square minus sin square is 1 sin square by cos square. Now sin square plus cos square is 1. Trigonometric identity, sin square plus cos square is 1 by cos square. Then 1 by cos square is sec square, and integration of sec square is the basic integration formula. It is 10x plus constant. You can see opposite also, reverse process of differentiation. Dx of 10x is sec square. So integration of sec square is 10x. So it is correct. The next question is 1 by sine cos cube. Let us do it like this. We will multiply by cos, divide by cos. See, divided by cos, multiplied by cos. So value remains same. If we cancel this cos, remaining sign, so it is correct. So divided by cos x, multiplied by cos x. Now these two will take together. Here cos by sine is 10. These two together is cos power 4x. Then 10x. 1 by cos is sec. 1 by cos is sec, so it is coming out sec power 4x dx. Then sec power 4 we can write sec square x into sec square x. Some of the integrations you have to learn. If you practice, then only you will understand. Trigonometric integrations, we are using only trigonometric identities. Some of the questions you must learn, practice. Now 1 sec square will convert. First sec square converting, sec square is 1 plus tan square. Second sec square keeping as it is. We need it. We are going to do substitution method, divided by 10x. Now we will do substitution. Put 10x, put 10x equal to t. And differentiation of 10x sec square will come. That's why we need 1 sec square. We are keeping it to cancel with the differentiation of this. Look, first differentiate. You will understand if you do. Ddx of 10x is ddx of t. Differentiation of 10x is sec square x dt by dx. Then convert dx, it will be 1 by sec square x into dt. We need 1 sec square to cancel, that's why 1 sec square we are keeping here. Then the integration is changing. This is the integration changing now. 1 plus 10, we have taken t, so tan square is t square. Sec square is as it is. This 10x is t, and dx we have converted. Dx is 1 by sec square x into dt, and this is getting cancelled. So the process is correct. Now it is, we'll split it 1 by t and t square by t into dt. So finally it is 1 by t dt, 1 by t dt minus plus integration of only t dt. 1 by t dt is log t, basic formula, and t to the power 1 is 1 plus 1 by 1 plus 1 plus constant. So it is log of t plus t square by 2 plus constant. T is taken for 10x. So we'll put it back. T is taken for 10x. It is log of t. T is 10x. 10 t square. So it will be 10 square divided by 2 plus constant. The next question is cos 2x by cos x plus sin x whole square. We will use the identity here. Cos 2x is cos square x minus sin square x. This identity we will be using at first. Cos square x minus sin square x by denominator as it is. Now in the numerator we can use a square minus b square, a plus b into a minus b. Then the numerator is cos x plus sin x into cos x minus sin x. Denominator keeping as it is. It is remaining as it is, dx. Square and one term getting cancelled. Then remaining is cos x minus sin x by cos x plus sin x. Now this integration we must do by substitution method. We will put denominator equal to t. Very clearly we can understand, if we put denominator t and if we differentiate denominator, we will get the numerator. Numerator is differentiation of denominator. So substitution method, put denominator is equal to t. Then differentiate both sides. Cos differentiation minus sine. Sine differentiation is cos dt by dx. Then we are getting dx 1 by, we can make it cos minus sine dx. Then the integration is converting. Integration is now, it will be converted. Numerator as it is. Denominator we have taken t and dx is converted here. Dx is 1 by cos x minus sin x dt. And then this is getting cancelled. Finally remaining 1 by t dt. So the integration now coming under basic formula. Integration 1 by t dt is log of t plus constant. And t we have taken for cos x plus sin x. We can put it back. Cos x plus sin x we have taken for t. This is the complete solution. The next question is sin inverse cos x integration. This cos can be converted. Cos can be converted into sin. Sin pi by 2 minus x. Multiple angle formula, you know. Sin 90 minus theta is cos theta. and then sine inverse sine cancel, remaining pi by 2 minus x. Here we know sine 90 minus theta is equal to cos theta. 90 is pi by 2 minus theta is equal to cos theta multiple angle. Now sine inverse sine cancel, remaining this, and then we will separate the integrals. Pi by 2 dx minus x dx. Here pi by 2 is taken out because it is constant x dx. Pi by 2 1 dx integration is x, and it is x power 1 x n plus 1 by n plus 1 formula of integration. Then this is pi x by 2 minus x square by 2 plus constant. Next question is e to the power x into 1 plus x cos square e power x. Here we will do substitution method. We will substitute e to the power x into x is equal to t, and then differentiate. Let us see. d dx of x e power x equal to d dx of t. Differentiating both sides. We will apply product formula. U d dx of b, ub formula product, plus second d dx of first, right hand side dt by dx. Integration of x, d dx of x is 1. Integration, sorry, d dx of e remains same, is dt by dx. So finally e to the power x common, 1 plus x dt by dx. We will find out dx dt. Now the integration will convert, integration will change. Numerator as it is, cos square, this full term we have taken t, and we have converted dx here. Dx is 1 by e to the power x into 1 plus x into dt. Now this full term is getting cancelled. It is remaining 1 by cos square t, and integration 1 by cos square is, sorry, 1 by cos square identity, 1 by cos square is sec square. Integration sec square, we have the formula, basic formula. It is tan of t plus constant. The integration is done, and t must be removed, and t we have taken for e power x into x. So it is tan of e power x into x plus constant. This is the solution. The next question is 1 by cos x minus a cos x minus b. Now this question, there are certain questions, if you learn and practice, you will understand. Here multiplying by sin x b minus a, dividing by sin b minus a. Sin b minus a, there is no variable, so we can, from inside to outside we can take, no problem. Then in the next step, so this is the integration. This numerator we can make it x minus a minus x minus b. It is possible because x minus x cancel, minus minus plus, b minus a, so b minus a is correct. Denominator as it is, integration dx. Now this numerator whole term, this numerator we will apply sine of a minus b formula. Sine of, this is a, this is b. Sine of a minus b, we know sine a cos b minus cos a sine b. So this formula we are going to use in the numerator. Denominator as it is, sine of a minus sine a cos b. This is a, this is b. So sine a cos b minus cos a sin b. So we have divided. Now we will split first term by denominator minus second term by denominator. We will split it into 2. This is as it is. We will split it first by this. First by the denominator minus second by denominator divided by denominator cos x minus a into cos x minus b. Then here cos x minus b getting cancelled, and here sin x minus b cos x minus a, this is x minus a, sin a cos b cos a, this is x minus a, so cos x minus a getting cancelled. This is remaining as it is. Sin by cos is 10, this is remaining 10 x minus a, and this is sin by cos remaining 10 x minus b, so it is correct. Now we'll split integration of 10, we can directly do also. See, integration of 10 is log of sec, integration of 10 is log of sec, integration of 10 is log of sec, integration is complete plus constant c. So this is the complete solution of trigonometric integrations by trigonometric substitution and trigonometric identities. There are certain questions, if you practice, if you learn, then only you will understand.